going to learn about dimensional analysis today. Dimensional analysis will make your life very easy in chemistry once you learn the process. So we're using an imaginary planet called, let's see, Zenoon. No, that's close enough. And we see that there are two cities that are 36.2 blim apart. And we need to find that distance in krill. So we start dimensional analysis drawing tracks. In our track, we begin by writing the given amount, which is 36.2 blim, on the top left. And what we are solving for goes on the right. So krill will go up on the right. I'm going to bring blim down so that it will cancel out and leave us in krill. And now we're going to go up to the conversion factor. We see above that 1 blim is equal to 1,400 krill. Now when two numbers are side by side, of course, we're always going to multiply. So to solve, it will be 36.2 times 1,400. When I solve in the calculator, I'm going to first clear, and I will put in 36.2 times 1,400, and that equals 50,700. So continuing on, and we'll get rid of our calculator at this point. The average Sydney's is 170 krill tall. What is the height in blims? Again, these are imaginary units of measurement. So I'll do my track. The given amount of 170 krill will go on the top. And I'm in krill, I'm going to bring krill down, and I'm solving for blim, and I will put that on the top. Now I look up above at the relationship between blim and krill, and I see that 1 blim equals 1,400 krill. Now krill cancels. We are now in blim, and we're ready to solve. In this problem, we will take 170 and divide it by 1,400. My resulting answer then will be 0.12 blim. Okay, moving on down the page. We'll use some measurements of units that you're a little more familiar with. At the mall, you decide to try on a pair of French jeans. Naturally, the waist size of the jeans is given in centimeters. What does a waist measurement of 25 centimeters correspond to in inches? So inches is what we're looking for. Start by drawing our track. And in that track, remember the top left, always we put our given amount, which is 52 centimeters. We bring centimeters down, and we're solving for inches, so that goes on the top. Now we're going to go up to the top of the page, and let's look at the relationship between centimeters and inches. There are 2.54 centimeters in 1 inch, so I'll come back and write 2.54 centimeters in 1 inch. Now, before I solve, I'm going to cancel my like units, and we're ready to solve. In our calculator, we will plug and chug do that math. And 52 divided by 2.54 equals, this is quite a sizable number, I'd say. But we know sig figs, so we are good to go. And I'm going to actually note that we have 3 sig figs here and 2 here. My answer must be in 2 sig figs. The answer for 2 sig figs would be 20 inches, but that doesn't show us sig figs of 2, so we have to report it in scientific notation. And these are inches, okay? Again, the trailing zeros are always significant when there is a decimal. All right, so we're now looking at a pharmaceutical mass. Aspirin contains 5.0 grams. We're asked to find the quantity in 2 tablets expressed in grams. I'm sorry, I mispronounced that earlier. This is grain. These are grains, not to be confused with grams. So we'll draw our track. Top left will go the given amount. Of 5.0 grains. I will bring grains down, and I'm going to go up and put grams on the top. Going up to the top of the page, let's take a look at that relationship. There are 15 grains in 1 gram, so we'll come back and write 15 grains in 1 gram. In our calculator then, we will plug and chug again, so that is 5.0 divided by 15, and that gives us 0.3, 0.3, and let's think about sig figs. We need to have 2, so it's going to be 0.33 grams. I did overlook canceling of the grains. One of the most important steps with dimensional analysis is it allows you to double check and make sure that you're in the correct unit. Alrighty, we're going to go on down to another non-SI unit. SI refers to Scientific International. These are units of measurement that are used throughout the world. Scientists find it extremely helpful because they can communicate their quantitative data internationally, which is very important. All right, so we have the hand, which is a unit of measurement, equal to 4 inches. And we're asked to find out what the height in centimeters of a horse is that stands 16 hands high. So we're given 16 hands, and we need to find centimeters. So we're going to have a couple steps for this. Hopefully we know that conversion factor. My given amount is 16 hands, and we know that 1 hand, and that was told to us right up above, is equal to 4 inches. Okay? So we're in inches, we bring inches down, and we're looking for centimeters. So centimeters will go on the top. Scrolling up to the top of the page, let's see. What is that relationship? 2.54 centimeters in 1 inch. So we put 2.54 centimeters in every 1 inch. And now we go and we cancel like units. And we're left in centimeters, which is what we want. And we will solve using our calculator. Let's take a look at this. I want you to watch closely because these steps are straightforward once you get the hang of it. Whoops. I lost my calculator. Let's go back. Pull that up. You'll have to disregard that line I just drew. And let's take a look. We have 16. And we're going to multiply straight across. 16 times 4 times 2.54. Now, I like students to multiply straight across and get an answer, and then divide. Now, in this case, the number we divide with is 1, so we don't have to do much with that number, of course. Those numbers, other problems we do this year will require us to. So our final answer has to be in 2 sig figs. So I will report that as 160 centimeters. Okay. All right, on to number 5, which is something you're a little more familiar with. Here we're working with 5.62 teaspoons, and we need to convert it to liters. This problem will take a number of steps, and we'll probably have to go up and down the page to get our equality statements. All right, our given amount, 5.62 teaspoons. And we're going to go from teaspoons, which I abbreviate. We're going to need to go to tablespoons. Going up the page. Teaspoon, 1 teaspoon, 1 tablespoon is equal to 3 teaspoons. So we will plug that in. I'm going to do a capital T for tablespoon. That's what I tend to do at home when I'm cooking. So 1 tablespoon equals 3 teaspoons. Now you'll notice that our teaspoons cancel. We're left in tablespoons, which we don't want. We want to get out of those tablespoons, and we will do that by setting up another relationship or equality statement. I'm going to bring tablespoon down, and this time I'm going to convert to cups. And going up the page, we see that 16 tablespoons equals 1 cup. So we're going to go right back down, and we will write 16 for 1 cup. 16 tablespoons in every 1 cup. We have another step. We will bring down, well, first I should say, important step, tablespoons cancel. We're left in cups, but we need to get to liters, don't we? So I'm going to bring down a cup. And from there, I will go to a pint. I'm going to abbreviate that as PT. We'll go up to the top of the page and note that 2 cups equals 1 pint. We'll go and plug that into our dimensional analysis, and we'll put 2 cups equals 1 pint. I'm going to go and cancel out my cups. I'm left in pints, and I'm almost finished, but not quite. If I'm in pints, I'm going to bring down the pint. And then going up to the top of the page, from pints, I'm going to have to go to quarts. 2 pints equals 1 quart. So I will put 2 here. and 1 quart on the top. Again, I'm going to abbreviate quart as QT. Now I can go and cancel out pints. I'm left in quarts. So I have another step. I've got to get to liters. We will go back up and find the relationship then that is between quarts and liters. And here we have 1 liter equals 1.06 quarts. Going back down the page, 1.06 quarts equals 1 liter. And now I'm able to cancel out of quarts, and I'm ready to solve. I will pull up our calculator, and let's take a look at how this will work. This is a good example for students to see how to solve when we have numbers in both the numerator and denominator. Again, I recommend that you multiply across, so that'll be, oops, I guess this isn't on. Let's try it. All right, let me clear it. So that's 5.62. And my problem, we have nothing but the number 1. So we don't have to do anything at that point, but we're going to start to divide. And we will divide that by the 3 tablespoons, or rather teaspoons. And I recommend you just hit enter. Then you're going to divide that by 16 and hit enter. You will divide it by 2 and hit enter. And divide it by 2 again and hit enter. You can see our numbers getting smaller and smaller. And then finally, we will divide by 1.06. So our final answer is fairly large. Let's see how we would round that to sig figs. Our starting number was in 3 sig figs, so my final answer will have 3 sig figs, and it would be 0.0275 liters. All right, almost down. We're to the last problem. Now here we're working with atoms and moles. Now in chemistry class, we will spend a great deal of time working with atoms and moles. These are somewhat new concepts to you. Mostly moles, probably, I would imagine you have not been exposed to. Atoms, I'm sure you heard about in middle school science, and we talked about that even earlier in the school year. So we're going from atoms to moles. We're going to start by the basic conversion factor, which is actually up at the top of your page, and that tells us that 1 mole is equal to 6.02 times 10 to the 23rd. 1 mole of anything is equal to that number value. So we'll start again by putting your given amount, which is 4.56 times 10 to the 25th atoms. That goes up. I'm in atoms, I'm going to bring atoms down, and I'm solving for moles, and moles will go on the top. Now, again, going back up, we see that 6.02 times 10 to the 23rd atoms equals 1 mole, so we will plug those values in. 6.02 times 10 to the 23rd atoms equals 1 mole. Now we'll cancel atoms, and we are left in moles, which is what we've been asked to solve for. So pulling up our calculator, let's plug that in. I'll do this using the scientific calculator, and the exponents. Remembering, of course, those of you with 4 function, you will simply subtract the exponent. So 4.56, and we hit second EE, and then the exponent of 25 divided by 6.02 second EE and 23. And here's my answer. Now, we started with 3 sig figs, so the final answer will have 3 sig figs. That would be 75.7 moles. And that is your first work with dimensional analysis.